what I'd like to do now is show you how to build an interactive program. The value of building an interactive program, of course, is that now we can actually, deploy it live. And what I'm going to do first is I'm going to show building an interactive program with a command line interface. And that's not because command line interfaces are especially desirable. It's just that they're easy to build and they actually show kind of the core ideas. Because what we're gonna find out is actually there's nothing special that we need to do to launch the program with Reach with any particular user interface. We're actually not going to need to open up the Reach program again at all. The only thing we're going to be doing is modifying a JavaScript program. And this JavaScript program is just written in plain Jane JavaScript. Now, of course, what that means is that you could embed this program inside of a larger JavaScript application. For example, if you wanted to do something like use Electron or something like that to build a desktop application that was written in JavaScript, you could embed this inside of that, so that now you have a Reach program in part of a desktop JavaScript program. Or you could write the JavaScript program so that it uses a library like React or Vue or something like that, and then launch it on the web. Now, using all of those technologies to build GUIs, it's a lot of specific programming information relative to how to build things for that library. And for the same reason, we don't want to, we chose the rock, paper, scissors domain because it's simple. We're going to choose command lines because it's simple. So let's walk through now how this is going to work. So the first thing that we're going to do is I'm actually going to copy this file right here. And I'm going to call it auto.mjs because it's going to be our automated test suite. And then what I'm going to do is I'm going to go and I'm going to modify it so that instead we're going to have one that is not automated. So it's actually not going to have two accounts anymore. It's just going to have a single account. And the reason it's only going to have a single account is because we're going to run two of them and they're going to be connecting with one another. And let's make it so that we don't keep track of, we'll say, here's what we have before, and then we'll go down here and we'll say, here's what we have after. After, we'll say account, and then we'll say, I went from before to after. So we're going to see kind of the same interface as before, the same output that is. So then the next thing that we need to do is we need to have it so that the program decides whether it is deploying or not. So basically what we're going to do is we're going to say that the contract is either am I deploying, and if I'm deploying, then we're going to do this. And if we're not deploying, then we're going to do this side. Now, because when we're not deploying, we need to get this information, what we'll do is we'll make it so that, actually, let's call it am I attaching? And if we're attaching, no, we'll do am I deploying? If I'm deploying, then we need to get this information. Hold on just one second. I got a baby hanging out up here, so just hold on one second. She's going to help me program. Okay, so we're going to have to get the information some other way. So I'm just going to write an extra function that's going to be called getInfo. And similarly, when I have this am I deploying right here, we're going to have to get that from somewhere. So yeah, we'll kind of play this by ear and we'll do this gradually. Okay. Let's see, what do we want to do next? Oh yeah. So what we'll have to do is we won't be running both sides. Instead, we'll only be running one side. And so since we're only running one side, we can get rid of some of the abstractions here. So what I'm going to do is I'm going to write a function that's called interact, or an object called interact. And it's going to start off as just being this has random thing. And then we'll say interact.getHand, and it's going to equal this code. So kind of what I'm going to do is I'm going to remove that object and the player abstraction, and just have the functions stand on their own. I guess another thing that I need to do is I'll change this who to you. You saw that this was the outcome. You went from before to after. Another one down here. You saw a timeout. And then we'll say interact.inform timeout equals this. Close that. Okay, what else do we need to do? Well, we need to say something like, am I Bob or am I Alice? And if I am Alice, then I'm going to set the wager. So I'll say interact.wager equals this. And then I'll say, otherwise, if I'm not Alice, then that means I must be Bob. So I'll have to say interact.acceptWager. And it's going to be this code. Now, I'm kind of writing this in a different way than the tutorial does, because the tutorial can't say things like copy and paste the code from over here over to over there. So this is the way that, you would actually do it if you were converting one to the other. So that's kind of what I'm showing now. Then we also have to know what backend to use. So I'll write backend equal, and I'll say down here, here the backend I want to use. Sorry, we'll call it which. We'll say which equals backend.alice. And then over here, we'll say which equals backend.bob. And then we can say down here, await which, and then we can say the contract and the interact object. And then once that's done, we know that it's over. Now, this is not actually going to work completely because we haven't actually defined this am I Alice function and whatnot, and the am I deployed function. But let's just kind of run to see what errors we get. When I program, this is the way I like to do things. I like to see what the errors are. Okay, so there's no, I wrote await, but I'm supposed to write async. It's just a dumb mistake. What else do I got? Next, we say, okay, I'm deploying not is not defined. Okay, so this is kind of a good thing to look at next. So since we're building a command line interface, we need to have some way of reading things. So if you look at the tutorial, we talk about how we have a little helper library that's called ask. And what ask does is it's going to just wrap saying something on the terminal and then reading a result back. So we'll do that, and we'll say down here, it looks like this. We say await ask, and then we say whether it's a yes or no question. So we'll say const am I deploying equals ask, are you deploying? And then it takes in a yes or a no. We'll say await. And then you're also supposed to call done at the end. Now you say, when you're totally done, you just call done. Okay, so if I run this, we'll make a little bit of progress. So it says, are you deploying? And I can say yes. And if I am, then it says, am I Alice isn't defined. I need to move on from there. So we need to figure out how to know if I'm Alice. So we'll say down here, we'll say const am I Alice equals await ask, are you Alice? And that's another yes, no question. Now, again, even though I'm just writing JavaScript that does a command line interface, there's really no difference in terms of JavaScript between calling this ask function that prints out something on the terminal and calling a similar function that comes as part of your web browser or as part of your GUI toolkit to pop up something. Now, even though, and similarly, like even though we're using the await idea here, we could just as easily make it so that this ask right here, like what it really does is it like sets state inside of the browser, which changes the way that the view is. And then when you click OK, it actually resolves that promise. Now it's more complicated to do that, but there's in principle no difference between it. So if you already have web app development experience, you're going to be able to do this as well. Okay, so we'll say, am I Alice? And we can ask that question, and then there's nothing else to do. So I can come back and I can say, are you deploying? Yes. Oh, you got to say yes or no. Am I Alice? Yes, I am Alice. So now I've gone off and I've deployed the contract. Now, the thing is that what needs to happen is that Bob needs to accept the wager. But we're not running another version of the program, which is Bob. So let's actually do that. Let's open up another terminal. Let's put it over here. And we'll load reach. We'll go into the reach file. We'll go into the tutorial. And we'll run another version. And this other version, it says we're deploying. No, we're not deploying. And then it says, oh, wait, there's no get info function. So I've got to go write that get info function. So we'll come back and we'll say, all right. So if you need to get the information, then we can write that. We'll say get info is an asynchronous function. And how does it work? So it kind of does something funny. So I need to just look up what we do, because we have to say, we have to call these two things. We have to call JSON parse. So we'll say that the info will return an await ask type out the info. Type out the info, that's what we want to say. Yeah, please paste the contract info. Please paste the contract info, and we'll say JSON.parse. And I guess that also means that when we're deploying, we should print out something. So let's just print it out all the time. Let's say console.log, say the contract information is, and we'll just print it out all the time. So we'll say await contract.getInfo. Yeah. So let's kill this. And actually, let me make another terminal window over here on the right, or on the left. That'll be when we run Alice. So in the middle will be the code that we're writing, on the right will be Bob, and on the left will be Alice. So we'll run reach run. Over here, we'll say, I am deploying. Then I'll say, I'm not Alice. I am Alice. And then we're rating. So now we'll go over here and we'll say something. We'll say, am I deploying? No, I am not deploying. Now I've got to paste the contract information. So I come over here and grab this, copy it, paste it, and it says unexpected token. This is kind of a frustrating thing. It didn't get put on one line. And because it didn't get put on one line, like the thing entered. So I guess I need to say JSON.stringify. And let's put it inside of here. We'll have to go back and kill this and run it again. So we can get it printed out in just a slightly different way. Yes, I am deploying. Okay, here's the contract information. Go over there, copy it, paste it, and hit enter. Okay, now it says, okay, we're attached. So now, am I Alice? I am not Alice, but this one, whoops. Go back over here. This one is Alice. Gotta stop typing. Okay, but this one is Alice, so I hit yes there. Now we see them run. So it says you played scissors, you saw the outcome draw, you played scissors, you saw the outcome Alice wins. Over here, we say you played scissors, you saw the outcome draw, played paper. Because the thing is that we haven't actually made it so that you get to choose. So let's make it so you do get to choose. So the first thing that we'll do is we'll change it so that Bob gets to decide if he accepts the wager. So we'll say down here, we'll say it like this. If await ask, do you accept the wager of format wager? And then that is a yes, no question. And then if you do, then you'll return. Otherwise, what you'll do is we'll just quit. So we'll say process exit 1. So we'll quit. Then what we need to do, so we'll change it over here so we can choose what your hand is. So we'll say over here that the hand is an await of ask, and say, what hand will you play? Now we have to have a function that will determine whether we typed in something right. And what we can do for that is, I'm just gonna see the way that I did it here. Okay, so we will just write a function that sees if it's in the list. So we'll say x goes to if, we'll say const hand equal hands x, and then we'll say if the hand is equal to null, then we'll throw an error, throw the error invalid hand, and we'll print it out. And then we'll return the hand. And then it'll say what we printed out. So we'll go up here and we'll make a little mapping where we'll say hands equals what. So basically we'll list out what the different options are. So you can say rock and that's 0. You could say R and that's 0. You can say a little r and that's 0. We could say paper and that's 1. P and it's 1. Little p and it's 1, or scissors. Thank you. You brought me Air, Land, and Sea, a very good card game. Thank you. Scissors is 2. S, little s is 2. Okay, so I think that's pretty good. Let's run it again and see how it goes. So we'll run over here. We'll run over here. And then this one will say, am I deploying? Yes, I am. And this one, am I deploying? No, I'm not. Now we have to paste the contract information. So we'll come copy it and paste it in over here. Now, am I Alice? No, I'm not Alice. Over here, are you Alice? Yes, I am. Now it says, do you accept the wager of 5? It's not fun if we say no, so let's say yes. So let's say yes. Now, what hand will I play? Let's play rock. You played rock. What hand will you play? Well, let's play rock over here. Now we see that there's a draw, so we have to come back and play again. So I'll play rock again. I'll play rock again. And then over here, we'll play paper. So now we see that Bob wins. You saw the outcome that Bob won. So as you can see, what we did is we just wrote a normal JavaScript program using normal JavaScript things. We interacted with the console. We used async and await to delay the program running. We had it running on one side and on the other side. Everything just worked exactly the way that you would expect it to. Now, our program, it's a little bit longer than before, but now it's a fully interactive application. I'll come down here. And if we were using a different library than this library, we would be able to give a better user experience. So what's the gap between this code right here and a real web interface? Well, it turns out that the gap between these things is all exertion and very little thinking. So it's sort of the classic example of a simple matter of programming. So we can go over to oh, by the way, there are things that the tutorial does that I didn't mention that you don't actually need to do, but it's useful to have the tutorial talk about them so it can explain other things. So before I move on to the web stuff, I just want to briefly comment about what those things are. One of the first things that we do in the tutorial is we also explain how behind the scenes, every time you run reach run, it goes off and it builds Docker images for your program. And when you're really deploying a reach program in practice, you don't want to use the Docker images that we build for you. If you're deploying to some, containerized cloud service, then you probably want to build your own Docker images. And so you can run reach scaffold, and what it will do is it will output the basic Docker configuration files that we do, and then you can look at those and adapt them. But now you don't have to use Docker. That's just what we do to make it so that we don't have to make sure that you have certain things installed on your computer. And so because you don't have to use it, we also output the node package file so that you could directly install it on your machine. So if I wanted to, I could just run an Ethereum DevNet separate from Reach, and then just run this directly. Now, one of the things that you can do is you can run a command that's called the reach devnet. And what that does is it starts exactly the same devnet that we would have run for you. Now, it turns out that it errors right now because I'm actually already running the one from the tutorial because that already exists. But what reach devnet does is it says, okay, let's run a devnet for you. So you could run the devnet, directly install the node package, and then be on your way, and you don't need to worry about the Docker stuff. So that's one of the things that the tutorial also goes through that you can look at if you want. The next thing that the tutorial talks about is it basically tries to make it so that it automates this idea of you run one side, which is Alice, and you run the other side, which is Bob. All right, anything else I want to say about that? No, that's all. Okay, so I just want to emphasize that up until this part in the tutorial, those front ends that we've been building, you really want to think of those as automated test suites, not as what a reach front end is really like. What a reach front end is really like is something like this, but of course using the user interface library of your choice. So now let's look at, remember we're going to say about the web interface. Now if we do a web interface, we basically have to answer questions. What front-end library am I going to use for interacting with the DOM? I mean, I could just directly be manipulating the DOM, but that's not really something that people do very much anymore. So now there's a huge number of libraries that I could choose, and Reach works with every single one of them. And the reason Reach works with every single one of them is because when you're writing your Reach front-end, you're just writing normal JavaScript. Now, we have experience with people using Vue and people using React. Those are the ones that I know off the top of my head that people have built stuff in, but I think actually there's one other one that someone built. I just don't actually really know the names of these things, so they just bounce right off me. I forget what the other one's called, but someone did another one.
I think Svelte.
There you go. Yeah, Svelte. So someone built something in Svelte. Okay. So because of that, you got to pick one. So the tutorial walks you through using React. Why does it walk you through using React? Simply because that's the one that we picked to do the demo on. We could have picked anything to do a demo on, but we picked React. And I'm now about to start telling you about things that are extremely React specific. So be forewarned that we're now entering the domain of I'm telling you React specific stuff. But if you already have experience building web apps, then your knowledge will just apply. Now, one of the main things that happens when you're building web apps is that you typically do a process that's called packing, where what that means is that you'll take your node program and you'll smoosh it together into one giant JavaScript file that includes your program plus all its dependencies. Now, there are tools like Webpack and Minify, and I think Yarn is another one. They're all different ways of doing that. React has one way of doing that, and one thing that's kind of nice about React is that it includes that as part of its job. Whereas, again, if you're used to building things yourself, then you have some other way of using Webpack. Since the Reach standard library is just a normal node package, that means that whatever you already have experience doing, that is the same thing that will work. I'm just going over here to grab a link to the module. So if we go look at the node package, so it's just a node package that you can download, and you can install any way that you are already familiar with downloading node packages. But the tutorial assumes you're using React, and React actually takes care of that for you. Okay, next thing. When you're building a web app, one of the things that you're going to be doing is you're going to be running a local web server. And you're going to be using that local web server to serve your code that you just webpacked. And every time you change your code, you're going to want to update that. So again, this is something that if you are already building web apps, you know how you like doing this. Again, something that's nice about React is it actually has this built in as well. You start up a special React dev server, and that dev server monitors your file system. And every single time a file changes, it redoes the Webpack, reloads everything. And so you are then on your way to getting live updates. Okay, so those are sort of fundamental things that are going to be the same across all of these web app development frameworks, but they're just going to do it in very slightly different ways. And we don't really have any way to just uniformly tell you how to do that because it depends on what you choose. So what Reach does, when you really want to use React, we wanted to make a fast path for making it really easy to get started. So there's a command that's called reach react, and all that does is it basically does the stuff that you as a React developer would already know how to do. It creates that dev server that I talked about that automatically does the packing. And the one other thing that it does is it just runs reach devnet for you. It literally just runs reach devnet. So again, if you want to use something else, you just use reach devnet. Now, although this command line program is very simple, its simplicity also means it is, ugly. And to make it beautiful requires a lot more effort. So I want to give you kind of an overview of where the what the structure of a web app is going to be. So we're going to have, some CSS to give it style. We're going to have the JavaScript that actually runs the main thing. And then in React, there's this concept called a view. In a view, you can kind of think of it like a page. So there's a page for the application. There's a page for when you're the attacher. There's a page for when you're the deployer. And there's a page that's shared by all the players, whether they're an attacher or a player. There are certain components that are just normal JavaScript stuff, like having a mapping from hands to integers and from integers to outcomes. We're going to want to build what are called components in Reach. Components in React. And basically what a component is it's like an encapsulation of state that can be updated externally. And then when it gets updated, that can cause the view to change and other components to be enabled. So one of the things that we do in this example is we start off with a component that says, what account do you want to use? And do you want to use an account that's a test account? And then if you don't want to use a test account, then we ask the question, are you a deployer or are you an attacher? She got her keyboard. Then if we look at each one of the each one of these views, it's going to say whether or not you click the deployer button and will change the component to be the attacher component. Attacher in this is sort of what it means to be Bob, and deployer is Alice in our examples. Put that there. I want to focus on one view in particular, which is the get hand view, because I think this one is the one that is the most instructive for how, for what it's like to have a web app interacting. She's trying to grab my glasses. to have a web app interacting with reach. Okay. So here's the code. Let's make it bigger. So this picture right here says that we're going to have a div where decide if there was a hand, if there was a previous hand, then we'll put a little informative message. And then we're going to have a state variable that's going to record whether or not we're ready to receive something, and that's called playable. And then we're going to show 3 buttons, which are for playing a rock, paper, or scissors. And it calls this function parent play hand. So what is that parent play hand function? It's this function right here. So the player has the player itself is the interact function. So that interact object that exposes the functions to reach, it has random and has getHand. So let's really zoom in on this getHand function. It takes no arguments because it just gets called and it's supposed to return a number. And its job is to return, 1 for paper or 0 for rock to the reach program. So what we're going to do is we're going to make a promise. In this promise, its resolve handler is right here. And what we'll say is we'll say that we'll change the view to this getHand view, which I just showed you right here. And it receives these different components. And one of them is that resolve hand function. That resolve hand function is this play right here. Okay. So we'll now remember what that is. Sorry, it doesn't get this. We're saving that for later. It gets this play hand function. And so when we set the state to this, it's now going to pop up this display. And when you click that rock button, it runs parent.playhandRock. And what that does is it calls this function, which resolves that promise from before. So that means that this hand that came from this argument, which came from this code right here, that actually gets returned right there. And since it actually gets returned right there, then that means that we can return to the reach program. Here is what the number is. You clicked rock, and so we return 0. And so this pattern right here is extremely prototypical of how reach web apps work. You asynchronously get called from the reach program saying, I need this information from the front end. And the front end needs to modify the state of the front end so that it can get the user to give that information. And this is, of course, entirely asynchronous because you don't know when the backend needs that information. And you can't immediately give it because the user hasn't given it to you. So you need to modify your state so that it can get displayed, get collected, and then once it actually is collected, then you can update your state to view something different, such as we're waiting to see what happens, and we can then return back to the reach program. Now, in some situations, there will be multiple there will be multiple interaction callbacks when there's only one logical operation that you want to happen. So a good example of this is actually with Alice. Because recall, if we look at our reach program, one of the things that happens with the reach program is that Alice, we ask what hand she wants to play, but that hand doesn't get sent over the network. Instead, we send the commitment. Then we come back and we declassify it. And then when we're done, we declassify these and share them. So that means that in between the time when Alice does this, there's actually another event that gets generated from her computer. And I mean, what that means is that she's going to get a pop-up that's going to say, you're about to send some money on Ethereum. Because every time you do a publication, you're signing a transaction. Same with Algorand. You're causing something to happen. So if we wanted to be kind of like a better user interface designers, we would do something like, interact, and we would say, look out, you're about to reveal your hand. And we would call that function. And then what that would do is it would be another function on this component that would pop up a display so that the user would understand what this pop-up that they're about to see from MetaMask or from AlgoSigner or whatever, what it actually means. So I've given you kind of a broad brush about the whole process, and then we kind of zeroed in on one specific example. And I think actually that is probably the best way to explain this, because there's just so many details behind the scenes that it's really easy to get lost in those details and not really understand everything because you're just getting drowned. But maybe it will be useful to just kind of zoom in at one more thing. Like, where does the deployment process actually happen? Let's look at our command line version. In our command line version, we said, do you want to deploy? And if you do, we just said, account.deploy backend. The exact same code needs to run in a web application. It's just a matter of deciding what user interface you want to do to decide it. And so here's the way that it works in our React example. We have a button that's called deploy. So if you look at the views, let me go back here. There's a view called deployer views, and there's literally a button right here that's called the deploy component, and it says, type in what you want to wager, and then click this button to deploy. So it calls this deploy function. Now, what is that deploy function? Well, the first thing that it does is it goes off and it calls deploy on the backend. That's exactly the exact same code. See, the exact same code. We call account and we deploy it, because account is something that we've saved before, because we had one component, the first one that you enter, that says, what's your account information? And then from there we say, are you a deployer or an attacher? Now here we're in deployer, so we remember what that account was. We just call deploy in it, exactly like we did in the command line version and exactly like we did in the test. Then we're going to say, okay, right now you're deploying. I'm going to figure out what the wager is, because it was typed into that previous form. And then I go off and I start the backend. Now, starting the backend, in JavaScript, it literally returns a promise. But you, as a JavaScript programmer, should think promise means start another thread. And that other thread is going to asynchronously call back to me. And remember, this argument right here, this one, what that argument is the interact function. See? When you call the backend, you give it the interact function. So in this case, the interact function that it gets, or sorry, the interact object, is the entire React DOM, which is why it can call and get the getHand function and the seeOutcome function. So that's how the reach backend gives information backwards. And again, just like we printed out, here's the contract information when we wrote the command line version. What we're going to do is we're going to grab that information and put it inside of another view called the waiting for attacher view so that they can pop it up and see. So I think there's a picture of it somewhere. See, it says, please give them this information. And the contract information is unique to each consensus network. So it looks like one thing on Ethereum, it looks like something else on Algorand. And so this is what I mean by saying that when you write a Reach web application, it is exactly the same as writing that web application if there wasn't Reach involved. And one thing that could actually be instructive would be to design your program as if there was a centralized database running everything, and then just replace it with the Reach program, because you want to have exactly the same user experience. Maybe that's actually kind of bad advice, because dApps really do behave differently. There are weird situations that you can get with dApps that are less common in centralized applications, where you try to do something, but you can't do it because someone else has come and done it, or there's a timeout. It's just that in centralized applications, there could be these things, but it's just kind of relatively uncommon. Whereas in dApps, they tend to be very common, these kinds of things. Now, I kind of want to mention sort of one last idea, which is that remember that whole Webpack process that we had to do? Well, when you do a Webpack, what that does is it looks at your program and it grabs all of the dependencies, every single dependency, and it puts it into one giant honking thing. Well, one of your dependencies is the compiled output of the reach compiler. That means that the website that you actually are looking at includes in it the smart contract. This is kind of another idea that I think is important to wrap your heads around when you're deploying reach applications or dApps in general. If I were to make rockpaperscissors.com, rockpaperscissors.com is not where, like, it's not like I make rockpaperscissors.com and I also launch the rock paper scissors contract, and then rockpaperscissors.com connects to that contract. Instead, rockpaperscissors.com allows my users to launch their own contracts. And when they deploy their own contracts, those contracts basically like come out of a template, which is what I made, which is what is inside of this backend right here. So that means that building a dApp truly is decentralized because you are making it so that your users can launch programs. You're not launching, it's not like you launch a program and then they use it. You enable them to launch their own programs. Now, of course, there's a lot more to say about the practicalities of this, and in particular about how you would, like what is the monetization strategy? And that is beyond the scope of the tutorial. And in all honesty, it's an open question about what is the perfect way to try to do this kind of monetization on dApps. A pretty typical thing that happens is that the one that you launch, it will embed inside of it who you are, and it will like charge some sort of fee. That's a really typical thing. Or the one that the users, the one that the users launch will embed you and include some sort of fee. Another thing that's a relatively common idea is that you will launch another program, and then when the user launches a program, it attaches to yours, and yours adds value to it. And because it adds value, you can now basically charge for the functionality of that. And someone could, in principle, launch their own version of that central program. It's not really central because you don't really control it, but that unique program. They could, in principle, launch their own. But if they launch their own, they would not be able to provide as much value as you do when you launch it. And so those are kind of like, a very quick sketch of the ideas that people have for monetization. This is absolutely an open question. We would normally have questions at this point, but we didn't really have a good experience earlier when we had open interaction because of the trolls. So I think that the right thing to do would be to say that, have your questions on Discord. We're always there, interested in helping you get through. And what you want to do is you want to be able to get through the end of this tutorial. And let me tell you just like what's going to happen after this. If you read through the onward and further section, it explains it gives you an overview of where we went. That's interesting. And then what do you do after that? Well, there's a bunch of different paths that you could do. You could start what is called a workshop. Let's just go look at that real fast. What a workshop is you can kind of think of the tutorial as like you're in a class, and the class is divided up into 3 months. And so the first month you like learn the basics, and your hand is held as you learn things. And then like halfway through the next semester, then the next month, you like turn in your big project, but everybody does the same thing. And then after that, then it's like, okay, now you don't need as much hand holding. So here's a whole bunch of little projects. And then ultimately you'll choose, and then, that's what you do in that second month. You choose your own, you go through these little projects. And then at the end, you choose your own thing. That's kind of the way that the documentation is organized. And the workshop is a large number of little projects that you can do. So let's just pick one at random. So this one says an atomic swap. In this workshop, we implement an atomic swap or sell order, wherein a seller offers an amount of an asset, X of A, in exchange for a prescribed amount of another asset, Y of B, and waits for a buyer to complete the other side of the trade. This workshop demonstrates the use of non-network tokens. Now, this one is just a sketch. It kind of tells you a problem, but it doesn't actually have any details. If you want to look at the code for this, you can look at it in the GitHub repository, so you can go see how we did it. But some of these tutorials have more information. Like here's one, it's called the trust fund. This one says, we're going to look at another strategy for transferring funds. We're going to establish a trust fund. A funder will make an account. They'll wait a certain amount of time to access it. And if they don't, the funder gets it. If the funder doesn't claim it, then it's dormant and anyone else can grab the money. So from this preamble, we walk through, like, what is the problem here? How would you decide how to build this? Unlike the tutorial where we walk you through every single step, the goal of the workshops is to turn you into an autonomous dApp developer. So it walks you through how to do this. Okay, so that's what the workshops are. Another thing that you could do is you could go read about the theory of reach in the guide. You could go read in excruciating detail exactly the form of every single function that's in the reference. Another thing that you could do is you could go and learn about how you can use languages that aren't JavaScript. So you can learn about Python and Go. For you all, I believe that the plan that Michael's laid out for you, and Michael can correct me if this is wrong, is that you're going to choose one of the workshops to do, and BB is going to walk through doing one of them. And then after that, then you are going to choose one of the challenges that I've designed. So I came up with this big list of challenges that are things that are kind of on the same scale as the workshops, but they don't have any explanation behind them. There's just basically a sentence, and you're going to pick one of those, and then you're going to do that. And that is what the Bounty Hack is. The Bounty Hack is, can you do those challenges? And for all of those challenges, I'm happy to, give you my ideas, explain what the problem is, all that. That's the future of the Bounty Hack. But we're now we're at the dock. We're getting ready on the boat. You guys, I've told you how to, get on the ship. You're almost ready to go. Now you just gotta, put on your training, take off your training wheels, and get going. And I think that this is probably a good place to stop. We're scheduled to go to 7, but it's Friday night. We don't have to, work all night long. So it's been great having you. I'll see you on the Discord. And I see your reactions. Thank you for the thumbs up and everything like that. It's nice to know that everyone's paying attention and happy.